Good morning, my dear students. In the previous class, we discussed deriving some expressions for finding radius of nth orbit, energy of electron in nth orbit, and velocity of electron in nth orbit. Let us discuss some objective questions on previous concept. See this: the radius of which of the following orbit is same as that of the first Bohr's orbit of hydrogen atom? What is given? The radius of which of the following orbit is same? Same means equal as that of the first Bohr's orbit of hydrogen atom. First orbit of hydrogen atom. And the second one is we don't know. Which orbit we don't know. That's why say n. And atomic number also we don't know. Say z. Okay. We know radius of orbit formula 0.529 into n square by z. N value 1, z value 1, that is equal to here also 0.529 into n square by z. We don't know here n value, z value, but here we know first orbit, that's why n value 1. Hydrogen atom, atomic number 1. Okay, 0.529, 0.529 cancel. 1 square by 1, 1. Then n square by z is equal to 1. That implies n square is equal to z. N square is equal to z. Then go with options. N value 2 square is equal to, here helium atomic number 2. So but here 2 square 4 not equal to 2. So this option wrong. Now here lithium atomic number 3. N square value 4. So this is not equal to 3, not equal to 4. So this is wrong. And coming to this one, lithium atomic number 3. N square 9. So 3 not equal to 9. So this option also wrong. Now coming to the last option, beryllium atomic number 4. N square value 4 equal to 4. Hence BE3 plus is the right answer, because here we are getting n square is equal to z. Okay, in which option n square equal to z you can check, go through the options. Okay, then you will get. Okay, next one. See this: the change in velocity when electron jumps from the first orbit to the second orbit. Electron jumps from first orbit to second orbit, what velocity changes? We know velocity of nth orbit is equal to 2.18 into 10 to the power of 8 into z by n centimeter per second. You can take ratio v1 by v first orbit to second orbit. That's why you can take ratio 2.18 into 10 to the power of 8 common, so cancel. Then depending upon z by n, z value here given hydrogen atom, the change in velocity when electron jumps from the first orbit to the second orbit. Okay, don't worry, z value same, because same atom given here, same atom, so z value same. N value 1 by again z to second orbit. This is z value, z cancel. That implies v1 by v2 is equal to 2 by 1. Then v2 is equal to v1 by 2. That means velocity will become off. When electron jumps from first orbit to second orbit, then velocity will become off. Okay, then what is the right answer? Of its original velocity, because v2 is equal to v1 by 2. That's why velocity will become off. Then of its original velocity is the right answer. Okay, next one. See this: which one of the following statements is not correct? First one, Rydberg constant and wave number have same units. Wave number nu bar is equal to units centimeter inverse or meter inverse. Rydberg constant r is equal to again centimeter inverse or meter inverse. So both are having same units. So first statement is correct, but asking wrong statement. Lyman series of hydrogen spectrum occurs in the ultraviolet region. Yes, correct. Lyman series obtained in ultraviolet region. Lyman UV, Balmer visible, and Paschen IR, bracket IR, and Fund also IR. Okay, so Lyman series of hydrogen spectrum occurs in the ultraviolet region, also correct statement. Third one, the angular momentum of the electron in the ground state of the hydrogen atom is equal to h by 2 pi. Angular momentum mvr is equal to nh by 2 pi. nh by 2 pi. The angular momentum of electron in the ground state of hydrogen atom. Hydrogen atomic number 1. Electronic configuration 1s1. 1s1. Ground state means electron present in first orbit. That means n is equal to 1. n is equal to 1. Then angular momentum of electron equal to h by 2 pi. Here also given h by 2 pi. So first 3 statements are correct. Automatically fourth may be wrong statement. The radius of the first Bohr orbit of hydrogen atom is 2.116 into 10 to the power of minus 8 centimeter. The radius of the first Bohr orbit of hydrogen is not 2.116. That is equal to R1 of H is equal to 0.529 into n square, 529 angstrom units. Angstrom unit means 10 to the power of minus 8 centimeters. This is the value. Radius of first orbit of hydrogen atom is equal to 0.529 into 10 to the power of minus 8 centimeter. 10 to the power of minus 8 means angstrom unit. Okay, but here given 2.116. Hence, this statement is wrong. Hence, here asking wrong statement. That's why, according to the given question, fourth statement is the right option. Okay, next one. The ratio of the radii of the first 3 orbits in an atom of hydrogen. We know Rn is equal to 0.529 into n square by z. Formula angstrom units. Okay, the ratio of the radii of first 3 orbits. First 3 orbits. R1 of is to R2 is to R3 is equal to, in an atom of hydrogen atom, H 0.529 common, so cancel. Then depending upon n square by z, n value 1, so 1 square by 1 is 2, n value 2, so 2 square by 2, n value 3, so 3 square by this is 1 because atomic number 1. Here n value 3 square, atomic number of z, atomic number of hydrogen 1. Then 1 is to 4 is to 9. 1 is to 4 is to 9 is the right answer. First one is the correct answer. 1 is to 4 is to 9. R1 of H is to R2 of H is to R3 of H. Okay. First radius ratio of first 3 orbits of hydrogen atom depending upon n square by z value. Okay. Next one. The radius of hydrogen atom in the ground state is 0.53 angstrom units. The radius of Li2 plus in the similar state means same ground state. Okay, see, given we know Rn is equal to 0.53 into n square by z. This is the radius of given radius of hydrogen atom. Radius of hydrogen atom for Rn is equal to RH into n square by z. N square by z. Okay, here what we have to find? Li2 plus same orbit Li2 plus, then same orbit means first orbit of Li2 plus RH 0.53 into n value 1 square by z value lithium atomic number 3, that is equal to, so 0.31 jar 3, again 37 jar 21, again 2, 36 jar, almost 0.176. Got it? So 0.176 is the right answer. Why? Because this value indicate RH, radius of hydrogen atom. Actually 0.529, but here given particular value 0.53. taken as 0.53. So we can generally equation Rn is equal to Rh into n square by z. This value 0.529, but here given 0.53, so no problem. So you can take that value 0.53 into n square by z. N value same orbit, so 1 square. Z value lithium 3, so 0.53 by 3, 0.176. Hence this is the right answer. Okay, now next one. In hydrogen atom, the kinetic energy of electron. Next one, the radius of first Bohr's orbit for hydrogen is 0.53 angstrom units. The radius of third Bohr's orbit would be, okay, here given what? The radius of first Bohr orbit for hydrogen is 0.53 angstrom units. So general equation Rn is equal to Rh into n square by z. R3, we have to find R3 because third Bohr orbit, R3. Rh given 0.53. In case particular value not given, you can take 0.529 into n value third orbit 3 square by z value hydrogen atom 1. So 0.53 into 9, 9 3s are 27, 2, 9 5s are 45, 45 plus 2, 47. That means 4.77 angstrom units. Hence fourth one is the right answer. 4.77 angstrom units. General equation Rn is equal to Rh into n square by z. This value 0.529 or given value you can take 0.53 n square by z. This is the general formula. Rn is equal to. Okay. Next one. We know, see this question, the energy of second Bohr orbit of hydrogen atom is minus 328 kilojoule per mole. Hence energy of fourth Bohr orbit would be, okay, we know En is equal to minus 13.6 into z square by n square, and we know this value is equal to energy of hydrogen atom first orbit. Why? Because hydrogen atom z value 1, so 1 square. For hydrogen atom first orbit 1 square. So this value equal to energy of hydrogen atom EH into z square by n square. Okay. Here given second orbit of hydrogen atom E2 of H by, now what we have to find, fourth Bohr orbit would be, so you can take ratio E2 by E4 of H is equal to EH into hydrogen atom, so z value 1, so 1 square by n value 2, so 2 square by EH into n value 4, z value 1 square by 4 square. EH by EH cancel, 1 by 4, 1 by 4 square, 1 by 2 square, 1 by 4 square, reciprocal, 16 by 4, that is equal to 4. So E2H is equal to 4 into E4H, because this value 4, 1 by 2 square by 1 by 4 square, reciprocal, 4 square by 2 square, 4 square 16, 2 square 4, 4 4s are 16. Now what we have to find? E4H, fourth Bohr orbit. So E4H is equal to, this value given what? Minus 328 kilojoule per mole by 4, that is equal to 4 8s are 32 and 4 2s are, so minus 82 kilojoule per mole. Fourth Bohr orbit of hydrogen atom, minus 82 kilojoules. Okay, hence second one is the right answer. Okay, take ratio. Main formula this is En is equal to minus 13.6 into z square by n square. This value is equal to energy of hydrogen atom first Bohr orbit. So EH into Z square by N square. So now take ratio E2 by E4. EH cancel. Z value 1 because hydrogen atom, N value 2 square. EH into Z value 1 square, N value 4 square. Okay, E2 value given. E2 value by 4. Then we get minus 82 kilojoule per mole. Okay, next one. Which of the following transitions in hydrogen atom will require the highest amount of energy? Highest amount of energy. We know if energy gap increases, then energy also increases. See, already we discussed in hydrogen spectrum. See, top to bottom energy gap increases, bottom to top energy gap decreases. This is N value 1, 2, 3, 4, 5, 6. Okay, now N1 1 to N2 2. Here N value 1 to 2, that means this gap. 1 to 3 means this gap. 1 to 3. Next one. 2 to 1, 1 to 2 or 2 to 1 same, this gap. 3 to 4, this gap. Where the energy gap more? Here energy gap more. If energy gap increases, then energy increases. Why? Because we know Bohr's orbit, already we discussed in Bohr's atomic model. If N value increases, then the energy of orbit increases. 1, 2, 3 increases, the energy also increases. Okay, that means here energy gap increases, then energy also increases. Where the energy gap more? N1 1 to 3. Hence, this is the right answer. 3 to 1. Okay, next one. The energy of an electron in the first Bohr orbit of hydrogen atom is 2.18 into 10 to the power of minus 18 joules. Its energy in the second orbit would be same. You can take ratio. Previously we discussed. The energy of an electron in the first Bohr orbit of hydrogen atom is 2.18 into 10 to the power of minus 18 joules. Its energy in the second orbit would be. Okay. We know general formula En is equal to E1 of H into Z square by N square. Z square by N square. This is the main formula. Okay. Asking what? Second orbit E2. First orbit energy given already 2.18 into 10 to the power of minus 18. 2.18 into 10 to the power of minus 18 into Z value. Same atom, hydrogen atom. So Z value 1 square. But which orbit? Second orbit. So 2 square. So 2.18 by 2 square. 2 square means 4. So 2.18, okay, 0.5 and 4s are 16 and also 2, 5 into 10 to the power of minus 18. 10 to the power of minus 18 or 5.45 into 10 to the power of minus 19. Hence, third one is the right answer. Okay. 5 point here 0.545, we are getting 0.545, but here not in the option 0.545, but given 5.45. 5.45 means here 10 to the power minus 18 will become 10 to the power minus 19. Okay, no? Hence third one is the right answer. Okay, next. See this question. The velocity of an electron in the fourth Bohr's orbit of hydrogen is v. The velocity of the electron in the first orbit would be. Okay, fourth orbit given, asking first orbit. Okay, we know Vn is equal to V1 into Z by N. This is the formula. V1 means that is the velocity of hydrogen atom in first orbit, that is equal to 2.18 into 10 to the power of 8 centimeter per second. Okay, now V4 given. V4 is equal to V1 into Z value. Which atom given? Bohr's orbit of hydrogen atom 1 by n value 4. Then V4 value given V is equal to V1 into 1 by 4. Then V1 is equal to 4V. V1 is equal to 4V. This is the main equation. Vn is equal to V1 into Z by n. That is equal to V1 value here 2.18 into 10 to the power of 8 centimeter per second into Z by n. Z by n. Okay, V1. We have to find V1. So V1 is equal to V4. V4 is equal to V1 Z value 1 because hydrogen atomic number 1, 4th orbit 4. So then V is equal to V1 into 1 by 4 because V4 value given V. So V1 is equal to 4V. Hence 4V is the right answer. Okay. Next one. See this. If the electron falls from n is equal to 3 to n is equal to 2 in hydrogen atom, then emitted energy is, okay, we know En is equal to minus 13.6 into Z square by n square. Now electron jumps from n is equal to 3 to n is equal to 2, that means third orbit to second orbit. So then you can take difference E3 minus E2, that is equal to delta E, that is equal to delta E. E3. So here minus 13.6 Z square common. Why minus 13.6 Z square common? Because hydrogen atom, given hydrogen atom. So minus 13.6 into Z square. Z square value 1 because hydrogen atom 1. So 1 square, this is common, into 1 by E3. So n value 3, 1 by 3 square minus 1 by n value 2 here, 2 square ratio. Then minus 13.6 into 1 by 9 minus 1 by 4. LCM 36. Now this one 9 4s are 4 9s are, then 5 minus 5 minus into minus plus, then if you calculate this value, then you will get answer minus 13.6 into 5 by 36. If you calculate this value, finally you will get 1.9 electron volts. Okay, this value equal to 1.9 electron volts. Okay, so here electron jumps from 3 to 2, that means E3 to E2. You can take ratio delta E is equal to E3 minus E2. E3 here 13.6 into Z square common. Why? Because 13.6 constant value, Z value same. Why? Because hydrogen atom. So 1 square into n value different. N is equal to 3 here, 1 by 3 square minus here 1 by 2 square, n value 2. So after calculation you are getting 1 by 9 electron volt. Hence third option is the right answer. Okay. Next one. Series. If the velocity of an electron in the second orbit of hydrogen atom is x, the velocity of the fourth Bohr orbit will be, okay, same, Vn is equal to V1 into Z by n, V2 by V4. Take ratio. Whenever given this type of questions, you can take ratio simply. Okay, then V1 cancel, Z value, hydrogen atom, that's why Z value also same, then depend on n value. So 1 by 2 by 1 by 4, V2 given, V2 value what? X. second orbit of hydrogen atom is X, V2 given X by V4, that is equal to 4 by 2, 2, then V4 is equal to X by 2. Okay, now? So this is general formula. Vn is equal to V1 into Z by n. Here V1 is equal to 2.18 into 10 to the power of 8 centimeter per second. Okay, now take ratio V2 by V4. Z value same, V1 same, that's why cancel. So 1 by n, 1 by 2, second orbit, again 1 by n, 1 by 4, fourth orbit. So after calculation you are getting V2 value given X. Asking what? V4. So V4 is equal to X by 2. Hence fourth one is the right answer. Okay.